Welcome! Today, we're exploring the hydrological cycle, rivers, and deltas. Through the hydrological cycle, or as many call it, the water cycle, water moves continuously through land, air, and oceans. This closed system, powered by the sun, also drives the flow of rivers that shape landscapes and form deltas where they meet larger bodies of water, creating vital ecosystems. The cycle begins with evaporation. Solar energy heats water in the oceans, causing it to turn into vapor. This vapor rises and condenses into clouds. Eventually, it falls back to Earth as precipitation in the form of rain or snow. Once the water reaches the surface, it takes multiple paths. Some of it infiltrates the soil, moving downward through tiny pores. If the soil becomes saturated, water flows across the surface as overland flow. Meanwhile, plants release water back into the air through transpiration. Through percolation, water descends deeper into the ground and becomes stored as groundwater. This groundwater may travel slowly toward rivers, lakes, or the sea through groundwater flow. Below the surface, there are distinct water zones. Non-saturation. Pore spaces have some water, but are not fully saturated. Intermittent saturation. Water temporarily fills pores after heavy rain. Permanent saturation. Pore spaces are always filled with water, forming the groundwater we rely on. In some regions, we find freshwater lenses, convex-shaped layers of freshwater floating above denser saltwater. These are vital for island communities and low-lying coastal areas. Water stored underground in rock formations like aquifers provides an essential resource. For example, springs occur when the water table meets the surface, while artesian springs or wells are powered by natural pressure from an artesian basin. But what about turning salt water into fresh water? That's where desalination comes in. In distillation, water is boiled, and the steam is condensed, leaving behind contaminants. With reverse osmosis, water is filtered and pumped through a special membrane, producing sediment-free water. Water storage happens both on the surface, in rivers and rainwater tanks, and underground in springs, artesian wells, and lakes. These systems are critical for both natural ecosystems and human use. Next is the impact of drainage density on flood risk. Higher drainage density, which indicates more streams in a given area, can lead to quicker water flow and a higher likelihood of flooding, including flash floods. Understanding this relationship helps in managing and mitigating flood risks in drainage basins. The drainage basin is an open system with precipitation as an input and evapotranspiration and water flowing into the sea as outputs. Water is stored in lakes, soil, and aquifers, while processes such as infiltration and runoff transfer water through the system. Drainage patterns differ based on geology and topography. Centripetal patterns form when rivers flow inward toward a central point, as seen near the Sea of Galilee. Dendritic patterns resemble the branches of a tree and occur in areas with uniform rock types, like the Mississippi River system. Parallel patterns are typically associated with steep slopes or faults, such as those in the Lesser Himalayas. Radial patterns develop around volcanic cones, like Mount Taranaki, and trellis patterns emerge in regions with alternating layers of resistant and less resistant rocks, such as the Appalachian Mountains. A hydrograph depicts the discharge of a river over time, where discharge is the product of velocity and volume. Several factors influence hydrograph results. Steeper slopes increase runoff speed, while permeable rocks reduce flooding by allowing water infiltration. Deep soils promote water absorption, and vegetation intercepts rainfall, reducing direct flow into rivers. Urbanized areas with impermeable surfaces heighten flood risk by accelerating runoff. River structures such as dams, the number of tributaries, and drainage density also shape hydrograph outcomes. Rivers evolve in 3 stages. In the upper course, steep gradients and vertical erosion create narrow channels, V-shaped valleys, waterfalls, and gorges. In the middle course, the land flattens, and lateral erosion shapes meanders and oxbow lakes. In the lower course, deposition dominates, forming wide floodplains, levees, and deltas as the river nears the sea. Deltas form where rivers slow down and deposit sediment at their mouths. The Nile Delta has an arcuate shape. The Tiber Delta in Italy is considered cuspate, while the Mississippi Delta is considered a bird's foot. Deltas develop when rivers carry large sediment loads, flow slowly, and deposit material faster than the sea can remove it. The formation process involves slowing river velocity, sediment deposition, and the creation of distributaries that spread sediment across a wide area. Next, we'll dive into the study of coastland processes, where the land meets the sea. We'll explore the forces shaping coastlines, from wave action to coastal landforms. The shore extends from the coastline to the shoreline, while the beach is the zone of sediment and sand deposited between these boundaries. The coastline itself is constantly reshaped by natural forces. Waves are created by the gravitational pull of the sun and moon, which causes ocean surfaces to oscillate. This oscillation creates friction between the air and water, forming waves through circular motions. Over time, the waves increase in size and eventually break on the shore. There are several types of waves. Deepwater waves feature varying wavelengths. Inshore waves have shorter wavelengths and break closer to shore. Constructive waves have a long wavelength and low height, whereas destructive waves are characterized by short wavelengths and high heights. Refracted waves occur when the seabed's depth varies, bending the wave's crest. As waves hit the beach, water is pushed up in the form of swash and drains back down as backwash, creating a constant cycle of water movement that shapes the beach. Water erodes the coastline through various mechanisms. Hydraulic action is the force of water pushing into cracks in rock, weakening it. Abrasion occurs when rock particles are thrown against coastal rocks, causing further wear. Attrition breaks down materials as they collide with each other. Solution is the process where soluble minerals in rocks dissolve in water. As waves erode cliffs, they form structures like wave-cut platforms. These platforms are areas of bedrock that are left behind as the cliff retreats due to constant erosion. When waves approach the coastline at an angle, they erode softer rocks more quickly, creating headlands and bays. The harder rocks form headlands, while the softer rocks erode away to form concave bays. Stacks form when headlands are eroded to the point of collapse. The sea breaks through weaker rock layers, leaving behind tall, isolated columns of rock called stacks. As waves force water into cracks in the rock, pressure builds up, creating a blowhole. When the pressure is released, water is forced out of the hole in a dramatic display. Geos are narrow coastal inlets formed by the erosion of rock along fractures. These unique landforms are shaped by both wave action and geological weaknesses in the rock. Longshore drift occurs when waves push material diagonally along the beach, with swash moving sediment up the beach and backwash pulling it back down. This continuous process moves sediment along the coastline. Coastlines feature various landforms, such as spits, which are narrow ridges of sediment extending from the land, and tombolos, where a bar of sediment joins an island to the mainland. Rias are submerged river valleys, while fjords are glacial valleys that have been flooded by rising sea levels, creating steep coastlines. Coastal areas face several challenges, including flooding, erosion, and pollution. To address these, various methods of coastal protection are used. For instance, seawalls deflect wave energy, rock armor, or riprap, protects the shore with large boulders, and groins disrupt sediment movement to prevent beach erosion. Gabions, made of wire mesh filled with rocks, are used to absorb wave energy. Timber piles and revetments are also used to reduce wave impact and prevent erosion. By understanding coastal processes and implementing effective management strategies, we can protect coastlines and mitigate the impact of natural forces. Thank you for exploring the dynamics of rivers and coastland processes with us. Please like this video, subscribe, and make sure to check out our other videos on the geography series.